if you have any papers that you have in mind, we can look at it afterwards. So we'll start here. Now, of course, my style is I love participation. Without participation, we'll not get much further than we are now. And so I ask that you participate whether or not you do know it or not. Participation will help us get to that point that we need to. It's always better to show what you know than to keep it there and don't realize that you don't know it. All right, so we'll start with, this is July 2010. Are you seeing my screen? What are you seeing?
Yes, sir.
So we're seeing participation is key
All right.
to get through these
I'm
stories.
going to change that slide so that you can see the question that we're looking at. So we'll do some questions, of course, try to cover as much content as possible and look at ways to properly answer the past paper questions. And the topics that we'll cover is everything that is on this list in some way, shape, or form. All of these are somehow intertwined. So you'll see some mixed questions that we'll look at. So let's start with June 2011 question 1. Let me bring it up. June 2011 question. All right, so this is the question. We all seen the question, right?
Yes, sir.
Yes, sir.
All right, so this question covers a multitude of topics. We're looking at electrolysis, we're looking at the mole. Of course, topics that are covered under the syllabus. And it gives you a table.
Yeah, but
You talking to me, Shanti? It gives you the question. It says a group of students conducted an investigation to determine the products of electrolysis. And copper sulfate was electrolyzed. Shanti, are you speaking to me?
Oh, sorry, sir.
I'm hearing somebody's TV in the background. Please mute. When copper sulfate was electrolyzed using copper electrode, following steps indicate the procedure used. Copper cathode was first washed with distilled water, dried and weighed, and then connected to a suitable circuit. Of 0.2 amp was passed through the solution, and the start time recorded. After 5 minutes, the switch was switched off, and the cathode was removed, rinsed with distilled water, dried in air, and then weighed. The cathode was returned to the circuit, and the process was repeated, recording the mass of the cathode at 5-minute interval. After each interval, the cathode was rinsed in distilled water, dried in air, and weighed until a total of 5 readings were taken. And this is the reading that we were given. Now, as the experiment told you, time was there, mass of the cathode was there, and then they added a field, which is the actual mass of the cathode, which was the positive. Now, from this from the table, you should already know what is coming, because of the nature of the test. Whenever you see blank spaces, means that you're going to have to fill out these blank spaces. And if you realize that there's a sequence, you should already be able to answer what these questions are asked. Fill out this table before actually seeing them asking you to do that. Can anybody actually fill out these tables? Can anybody recognize the trend that is present in these tables?
Sir, is it that the mass of the cathode is increased by 3?
Mass is increased by 3 each time or only one time?
So I know that the annual mass of copper deposited, that is increased by 2
Increased by 2.
each time.
Well, I think you mean 0.02. That's what you mean, right?
It's
0.02.
there, 0.02.
And yes, you would subtract, but subtract what? Solomon, go ahead.
Sir, the mass of the
Breaking up, Solomon.
sir.
Hardly. You're breaking up. I think we lost Solomon. All right. So we'll proceed and then we come back to the question when it's asked. So the first thing it does is tell you to define the term electrolysis. Anybody knows how to define electrolysis?
Yes, sir. The decomposition of ions through an electric current.
Decomposition of an ion through electrical current.
Yes, sir.
Anybody else?
The process by which electrolytes are decomposed by electric current.
All right. Anybody else?
Yes, sir.
Go
The
ahead.
chemical change occurring when an electric current passes through an electrolyte.
All right. That was a. Is there more? Or that's it. Let me get. All
Or I
right.
have one.
Go ahead.
So it's something about like the chemical bond elements usually and like an ionic substance that is either molten or dissolved in a solvent, like water that passes through electric current.
So like you're reading from Google.
No, I'm not.
Some documents. So. All right, that's extensive, but it asks for a definition that offers more of an explanation. I will reveal all of these in a minute or so. Next one says state the difference between the anode and the cathode.
Sir, the anode is a positively charged I call it your electrode, and then the cathode is a negatively charged electrode, sir.
All right.
And the positive ions go to the cathode and the negative ions go to the anode.
All right. There's one more difference that you can use. Anybody know that other difference?
Sir, anodes are attracted to anions and cathodes are attracted to cations.
Well, that does not tell the difference between anodes and cathodes. That's anion and cation. You have to recognize the terms that are being asked, as those are what will cause the problem. Anybody else?
Sir, a negative metal will go to the anode and a positive metal to the cathode.
That was said earlier, but there's only one thing that was left off. Let's go to it. Now, the only thing that was left off is the site of oxidation and reduction. Which one of those will have oxidation? Which one will have reduction here?
The
Anode, sir.
So oxidation occurs at the anode and reduction occurs at the cathode.
Nice. That was it. Now, the diagram, it says you must be able, based on the the objectives, you must be able to draw a circuit diagram. And based on the question that you are given, you're supposed to draw the diagram and label the cathode and the electrode. What would be the cathode and what would be the electrolyte inside this reaction? You put it back to the question. What would be the cathode and what would be the electrolyte?
The cathode would be copper, and then I think the electrode would be
electrolyte.
Copper sulfate. Electrolyte would be copper sulfate.
Copper sulfate. All right, that is correct. So let's go to the questions before the answers before we move on. So for the first one that we have done so far, electrolysis is the process by which an electrolyte are decomposed by electrical current that was said earlier. The anode is positively charged while the cathode is negatively charged. Other differences include negative ions will migrate towards the anode and it is a site of oxidation. Cathode is, however, negatively charged, and this is where positive should be cation will migrate, and it is a site of reduction. Everybody good with that so far?
Yes, sir.
Let me change this to cation so that nobody writes a screenshot incorrectly. All right, so this is our cell. Our cell has to have a source of energy on it. Cannot be a circuit without a source of energy.
Yes, sir.
It can have a resistor, may or may not have a resistor. It's optional based on what you. Somebody is speaking to me and I'm hardly hearing it. Yeah? All right. It may or may not have a resistor. So that's optional in the diagram. But what is important is that you have your electrodes, 2 electrodes that are completely or at least deep inside your electrolyte. If you just draw your electrode and you basically cut it off here and it is not touching the electrolyte, you will not get a mark for it. The direction of flow is also important. So this is positive. So the positive end of the circuit of the source should be positive as well. And the electrons are traveling in which direction? Is it positive to negative or negative to positive?
Positive to negative.
All right, so it is unconventional. And so this is our cathode. It is also, copper is also our anode. There is, what is this process? What is exactly happening in this process? Anybody knows? We call it a specific, we call this reaction a specific reaction. Not hearing it.
And endothermic reaction or exothermic?
No. This is used in the purification of copper, refining. You have heard that before? Refining of metals?
Yes, sir.
So the impure copper is the anode, pure copper is the cathode. Impurity is dislodged and falls into the electrolyte, and the pure copper will increase. Familiar to you?
Yes, sir.
All right. Now, you need this, you need the electrode to be submerged into your electrolyte. The electrolyte is the aqueous copper sulfate. You need it to be connected to a power source. Resistor is not that important. Ammeter also optional. And you must label your terminal in order to get the full mark. So you can make a note of that. Can we move on?
Yes, sir.
All right, now we have a table, the table that we saw from the beginning. And the table expects you to be able to recognize sequence. So it gave you some value, 0.03, 0.05, blank, 0.09, and then blank. Already you should see some pattern coming out. Then we move to the mass of the cathode, starting at 11.80, moving down to 11.83, which is corresponding to the 0.0 change. Sorry, 0.03 change. Then it blank. Then 11.83, that is blank. So what trend are we recognizing here? Somebody said earlier that it is increasing by 0.03, but if you follow the trend, that is not exactly so. Somebody said minus, but what exactly do we minus? Now, everything that happens in this reaction is going to be relative to the initial mass that we started off, which is 11.03. So if you add this 11.80 to the 0.03, you'll get 11.83. Therefore, if you add the 0.05 to 11.80, you would get?
Excuse me, sir. Can you start over?
Start over. All right. What, sorry, from the calculation, that's where you want me to start?
Yes, sir. How we would get the numbers?
All right, so this is the starting. All the reaction starts off with this, right? Now, this, based on this trend, everything here is linked in each row. If you had this to your initial, you'll end up with 11.83. If you add this to the initial, what would you get?
11.85.
11.85. And that sequence keep coming back, because if you now want to get this value, all you need to do is minus the initial from this value here. And what would you get?
0.07.
0.7.
11.07.
And here?
11.89.
This depends when you're not working. And then here?
0.1.
0.11.
Now, if you remember when I said earlier, this would be impure. And during the reaction, this impure mix, this impure substance will start to dissociate, disintegrate. Therefore, the impurity will fall at the bottom, and the copper will now get lodged here. So this will get larger, and this will get smaller. This is what it is showing you when it says mass deposited. So this is originally 11.8. At 5 minutes, this is 11.83. At 10 minutes, this is 11.85. Are you following what I'm saying?
Yes, sir.
Yes, sir.
So this process is important to know because you're getting I don't remember the top. Let me look at reactivity and extraction of metal. So this one comes under the extraction of metal, and this one is the refining of copper. All right. So of course I put the response here if you did not notice before. So at 10 minutes correspond to 11.85, 15 minutes 0.07, 20 minutes, 11.89, 25 minutes, 0.11. Ready when you are.
I'm ready.
Everybody good?
Yes, sir.
All right, let's go to the question. All right, so you know, it says plot the graph of the actual mass of copper deposited versus time using the axis in figure 1, and that is on page 5, which is this. Coming back to it. Then it says use the graph to predict the mass of copper that would be deposited after 28 minutes. Then write the Ionic equation to represent the reaction at the cathode. Now, these two will leave these two, but I'll take a suggestion for the Ionic equation because we need the graph for those two. What is your suggestion for the Ionic equation? Let me put it back so you can see the reaction. Oh, it's not done. That's the reaction. What is your suggestion for the Ionic equation?
So could we see copper plus copper sulfate? No, it never worked.
Can you repeat? This is what we know about the cathode. At the cathode, the positive cations will move towards. So if you're looking at the reaction at the cathode, what would be moving towards it?
Irons and hydrogen.
You're breaking up. All right, I look in the chat. So it is copper 2 plus 2 electron, so copper solid. All right, that looks good. However, the equation is missing something. But you're typing, so I can accept the issue there. So it's easy to know that if there's a positive cation that is moving towards, it will therefore mean that it is a metal that would be moving towards the cation. And there's only one metal in this electrolyte. What is that metal in this electrolyte?
Copper.
Copper.
The ion. Which copper?
Huge plus.
Copper 2 plus, specifically copper 2 plus. So copper 2 plus will always move to the cathode, and then it will be discharged because it is, of course, accepting electrons, and then it will become solid. So it will be discharged as pure copper, and this is why it gets larger. Any question? You probably just need to see it. So here we go. So with the graph, you are asked to plot the different points. We plot the different points. Because this stops at 25, we'll have to extrapolate the graph. And for this, you'll need a long ruler. So if you have a 12-inch ruler, that's what you need to carry. If you have a 6-inch ruler, you may need to adjust it so that you will reach the 28. After you have extrapolated your graph, this is your curve. You then find 28, and then from that 28, you go all the way up until you intersect your curve. After you've intersected your curve, You then move to the y-axis to find out what would be the actual mass deposited at that time. For me, I get 0.123 grams estimated.
Yeah, could you redo the graph, please?
Could I redo the graph?
Yeah.
All right, let me show you the graph is coming from. So this is the graph that they gave you. And you're supposed to plot your data points that you just created there, which is the mass deposited versus time. And this is what you will end up with. So these are the points that are in black. The blue is what I use to connect the dots to make my curve. And then I draw a straight line. Again, you have to use a long ruler. If you don't use a long ruler, then your curve may not reach to the 28, or you'll have to adjust your ruler to reach to the 28. After you have found the 28, which is here, you bring it all the way up until you reach the curve, and there's the intersection. Wherever the intersection is, that's what you'll use to estimate the actual mass that has been deposited.
So, sir, why did you put the other blue line, sir?
Which other blue line? This one?
Yes, sir.
This one is the 28 because this is the question. The question says, use the graph to predict the mass of copper that would be deposited after 28 minutes.
Oh, okay.
Everybody is on the same page now?
Yes, sir.
Yes, sir.
So when you have found the 28 and the line intersect, you then move to your y-axis, and that value that you get is the mass that will be deposited on your copper, your pure copper. And you can actually use your table to verify that it should be so, because at 25, whatever value you get at 28, it should actually be more than 11.91. And of course, the Ionic equation, which was submitted in the chat, yes, you can record. This is also recorded. I will upload it to 1x. I'm not sure if they give you the marathon link, the marathon recording, but I will make it available to 1x so that they can give it to you. So the Ionic equation at the cathode is, let's see, Abigail wrote it. And Abigail, these are the things that you are missing, right? It's minus sign, electrons are negative, so you have to have that there. And then, of course, everything else will be okay for you except for the state symbol, which is aqueous for the copper.
So do we have to have 2 electron negative, or could we just have the 2 electrons?
Here, 2 electron negative, see here? That's what I'm saying, that is missing.
Why do we have to put the negative on it?
Because we're looking at charged species.
Okay.
If it don't have the negative, you're saying it is not charged, just like this copper, which is actually not charged. Are we good? Can we move on?
Yes, sir.
This is also redox. If we were looking at redox, what kind of reaction would this be? Would it be an oxidation? Would it be a reduction?
This is a reduction.
Oxidation.
I'm hearing both. What is oxidation?
Oxidation is the gain of electrons.
What?
No, it's not.
Oxidation is the loss of electrons.
The loss of electrons.
Think oil rig. Oil rig. So oxidation is loss, reduction is gain. Are we losing electron or are we getting electron here?
Losing.
Losing electrons.
Sure.
Oh, gaining electrons.
There's copper 2 plus 2 electron, which becomes solid. We know from the periodic table that copper is in group 2. Well, it's a transitional element that is mostly in group 2. So it has a 2 plus charge, and it is gaining back that 2 electrons to become solid, which is no longer charged. So it gains electrons. And remember, cathode, what happens at the cathode?
Cathode. Me know, you know.
Reduction occurs at the cathode, oxidation occurs at the anode.
Me know, you know.
So this is gaining electron. And you can tell that it has gained because it moves from +2 to 0. And that means that it gets more negative. Any question? All right, good to go. Moving on to the other part of this question, which is about Coulomb, Faraday's charge, and the mole. So it says that the quantity of electricity that passed through the copper sulfate solution when 0.2 amps of current flows 20 minutes, that's what you're supposed to use to calculate the quantity of charge, and it gives you the equation. Therefore, they're making your work a little bit easier. So, how do we calculate the quantity of electricity?
The quantity equals to current times time.
And you
Current times
change
time.
it changes the second,
You change?
the minutes to second.
Nice. So Q is equal to IT. The unit for I is, of course, amperes. So that is already correct. And time, based on the equation, should be in seconds.
Can I zoom in, please?
Hold on, let me. And then, of course, time should be in seconds. So how do we calculate this time to seconds?
The 20 times 60.
20 times 60. Now, of course, this question does not end here because it asks you to calculate the number of moles. After you have calculated Q, you then need to take another step and compare it to the Faraday's to determine how much moles is actually created from this reaction. There are a few things that you must know, and that is one, Faraday's law tells you that 1 Faraday is equal to 96,500 coulombs, which is when you calculate Q, you'll get coulombs. And also, 1 Faraday is equal to 1 mole of electron. So you need to know how much electrons are produced in your reaction. How much electrons were produced in that reaction that you wrote earlier.
Sure, so would it be 2 times the 96,500?
Yes. So you are now comparing your reaction to 193,000 coulombs instead of the 96,500. Let me go back to the copper. So this is what it works out to. Quantity of electricity is equal to 0.2 times 20 times 60, which gives us 240 coulombs. And to find the number of moles, one electron will give you 96,500 coulombs. Two electrons therefore will give you 193,000 coulombs. And you divide this coulomb that you get by that gives you the number of moles. So the moles that we got is 1.24 times 10 to the minus 3 moles.
So where did you get the 2 electron from?
From the equation, which this equation. So this tells you that it is 2 electrons that is expected to be discharged. That says 2 moles of electrons. So that's what you should. So if it was not actually, let's say, copper, if it was something else, like let's use sodium. What is the charge on sodium?
+1.
+1, because it is in group 1. That would be aqueous. How many electrons?
1.
1 electron. And then it will give you sodium solid. So instead of comparing it to 193,000, we are now comparing it to 96,500.
So, sir, it would always move from aqueous to solid.
In a reaction like this, yeah, electrolysis, yes. Because electrolysis only occurs in 2 ways. You're either going to have an ionic solution or you're going to have a molten solid. For example, popular common molten solid would have been lead bromide. Popular common solution would have been sodium chloride. So sodium chloride, that would be aqueous, moving to solid. For lead bromide, it would be liquid moving to solid.
Okay, sir, thank you.
No problem. It is always dependent on the electrolyte itself. All right, so we have gotten the moles, and the last thing it asks for is the mass. We know from moles that to calculate mass, it is multiplying the relative atomic mass by the number of moles, which is 64 for copper, times the moles that we just found, which gives you 0.0796 grams. Can I proceed?
Yes, sir.
So the next question that was asked is, suggest reason for the difference between the mass of copper obtained from the table versus what you have calculated it to be. Why is there such a difference? Now, the difference, they actually gave you a hint of it inside the question itself, but you would have to know what you're looking for to actually get it correct. So let me bring you back to the origin of the question so you understand. So I told you that it was washed with distilled water, dried, and then weighed. It was also repeated that they washed it again, dried, and weighed. So most of the problem that you will experience is during that process of the drying and weighing. So the electrode was not fully dry, and there could also be a fluctuation in the current passing through the electrolyte. So the battery may be going. The source of electricity that you're using may be going. And the next question asks the difference in the reaction. If you replace the copper anode with granite, what would happen? In this case, you are not refining copper at that point because you're no longer using what we call an active electrode. We are now using an inert electrode. You have heard those two terms before?
Yes, sir.
Yes, sir.
How is the active electrode different from the inert electrode?
So the active electrode in the reaction while the inert electrode does not take part in the reaction.
Good. So the active electrode will take part in the reaction while the inert will not. So there's a few active electrodes. Anything that falls beyond hydrogen will consider itself to be an active electrode. So copper, gold, all of those heavy metals which are naturally found as solids can be an active electrode. So the difference is, if you are using an inert electrode, you will no longer get copper on both sides. You will now get oxygen being produced instead of the copper ion. And the oxygen will actually leave as hydroxide ion, but it will leave in the form of hydrogen gas. And there will be no no mass increase in the anode. No change in the anode because the anode is not reacting. So there's no decrease and there's no deposit onto the copper cathode. Any questions so far?
Yes, sir. One question. I remember first you stated that the impure copper was at the anode. Is that always going to be?
If you are doing a refining, yes.
So if any metal that you're doing, the impure one is always at the anode?
Yes.
Okay.
That is due to the movement of electrons because it will flow from positive to negative. So you will always want to start off with the impure so that electricity can start to destroy, dislodge any impurity from that product that you want. Send the electrons over so that the copper or whatever element you want to be pulled towards the cathode. Any other question? All right. All right, so let's do a quick look at qualitative analysis. This is 2012 question 1B. All right. Look at first. Then 2012 question 1B. All right, so this is our quantitative analysis table. Of course, you know, quantitative analysis, its intention is to identify possible cations, anions, or even gases in a given mixture. Now, the question says a student conducts number of tests and solutions of compound Y. Some of the observation and inference were made from the table. You're asked to complete by writing the observation and inference from I to 5. Now, for the cations are very straightforward. If it is a colored substance, it will be easier to pick out because copper is always blue, iron is either red, brown, or green. And you will always have these colors coming out. However, if it is white, you generally typically have a problem. And so you have to do some follow-up tests because you have a series of white substances, so calcium, zinc, aluminum. Lead. So all of those would be white and they are more technical, but once you see certain colors, you already know what to expect. So the precipitate of sodium, precipitate was formed from sodium hydroxide, and when it was added in excess, it becomes insoluble. And it told you that that precipitate is red-brown. What would be that substance that is produced?
Fe3 plus.
Fe3 plus, because iron is the only red-brown cation that exists. So, how would you write your inference?
Iron.
There are some typical ways that you write the inference. So, inference is always either a substance is either possibly present, it is either confirmed to be present, it is either present alongside with other substance. So for this, you have to tell whether or not it is present, if something is possibly present, or if it is present with other substance. So you say that iron is there, but are you saying that the iron is possibly present? Are you saying that the iron is present with something else? Are you saying that the iron definitely is present?
Definitely is present.
So the iron is present. All right. Then the next step, it goes down to say that a magnesium ribbon was added to the reaction. The magnesium reduced solution Y, and iron 2 plus ions were produced. So what observation are you expected to see? And this is 2 steps. So they're expecting you to say 2 things. They gave you 1. So there's 3 things that would happen. They gave you 1. What 2 things would you observe when you add magnesium?
Effervescence.
Expect to see effervescence.
So a color change.
What color change are you expected to see?
White
The
precipitate.
white or maybe
White.
White or crystal?
Colorless.
That's what they said, white or crystal? Yes, no? All right, seems like we're unsure about this one. Let us go to 3 then, because that one should actually be very easy, because we were given this inference here. What would be the balanced ionic equation? For when that green gelatinous precipitate forms that insoluble excess in sodium hydroxide.
NaF4.
No. First and foremost, what is this green gelatinous precipitate?
Fe2.
Iron 2.
Fe2 plus. So give me the ionic equation for the formation of iron hydroxide. That's what it is asking for.
Would it be Fe2
plus 2OH?
So give
FeOH2.
all right, and of course the state symbols are very important. All right, moving down to 4, it says dilute nitric acid was added, followed by barium nitrate solution, and there was no precipitate that is formed. what is possibly happening here. For the anions, as compared to cations, the cations only use two substances. Will either be sodium hydroxide or ammonia. For the anions, these use specific substances, specific chemicals. Once you see these specific chemicals, you can use them to identify what it is testing for. So for dilute nitric acid and barium nitrate, what would it be testing for?
What do you call it there? Acid, sir.
No?
Ions.
What was that?
No.
They actually give you a hint in the next step. Can you see the hint?
The test for the presence of gas, sir.
No. Yes.
Are they testing for chloride ions?
For?
For chloride ions or
Mm.
atoms?
Well, not specifically chloride ions, but elements that exist in those group, in that group. What are those ions called?
Anions.
No. They're the
Halide.
same group, halide. So this is a test for halide. For barium, for bromine and iodine, the precipitate would not disappear. For chlorine, the precipitate will disappear. So where it says no precipitate form, it is telling you that chlorine is the only one that is possibly present. Then, of course, the addition of the silver nitrate followed by the aqueous ammonia confirms the presence of the chloride ion. And they're expecting that you will observe something. So what would you observe to know that it is actually present?
Sir, the sun would turn pale yellow, sir.
When you turn yellow. All right.
Yes. And the pungent smell.
All right. So let's look at. So for the test one, it is iron Fe plus. We know that that one was definitely present. That's what you told me. For the test two, you'd observe two things: a white or colorless solid, as well as the silver gray solid of iron. Those would settle there as well. Then when you add the sodium hydroxide, it will form iron 2 hydroxide. For the test 3, when you add the test for halides, chlorine is the only one that would be possibly present because the precipitate disappeared. If the precipitate remained, chlorine would be the only one that is absent, and bromine iodine would be present on the reverse because their precipitate will not dissolve. And then, of course, the last test, you will see a white precipitate form. This one, go ahead.
Sir, I was asking if you could like redo the table with this because I don't understand.
Go back to the table. So for the table, we are saying that Fe 3 plus present. For this, we are saying that we might get some white precipitate or colorless, depending on the amount that is there. Can that might be muted, please? Dino? silver gray solid would be settled at the bottom of iron, of course. Then the balance equation would have been Fe2 plus of course, this is aqueous. 2 electrons. Sorry, wrong thing I'm writing. Sorry about
So, sir, for this equation, sir, why didn't we have Fe 2 plus NaOH to FeOH 2 plus Na?
why you get only Fe2 plus?
No,
Plus?
I was asking
Repeat.
why was the sodium not present in it?
All right. Sodium is known as a spectator ion. When you are writing aqueous equation, anything that does not change when it is a reaction, if it doesn't change state and it goes back into the product in the same state, it is automatically omitted. So sodium hydroxide would have been aqueous. When it goes back into the solution, it would have still been aqueous, but it would be left in the solution. It would not be a solid.
Okay, sir.
All right, this writing thing not working out too well at all. But it's on the PowerPoint, so let me put it on the PowerPoint if you're finished using this. Ready when you are. Water finish. Give me a minute, please. Ready when you are.
Ready, sir.
Ready, sir.
All right, so we're moving on to another electrolysis, which is on the same year, 2012. And this is question 2. So in this one, they actually draw the diagram, and it is similar yet different to the first one that we did. Can anybody recognize the difference?
Sir, different electrodes.
Using platinum electrodes.
The electrodes are definitely different. So in this case, we are not really looking at refining copper. So we have the copper anode, copper cathode, sorry, platinum anode, platinum cathode, the electrolyte is copper sulfate. Already you should know that there's some difference in reaction that you will get because of that. So let's proceed. Deduce the oxidation state of copper sulfate. I did not tell you which topic this is. This is electrolysis and redox. So how do we determine the oxidation state of sulfur?
So is it 2 minus?
2 minus. All right, I hear 2 minus. Any other suggestion?
+6.
Plus 6. All right.
Positive 6, sir.
What was that? Oh, okay.
Positive 6.
Positive 6. All right. If nobody else have any other suggestion, let's check. Let's work it out. So it is copper sulfate. Now, if you don't like maths, this will probably bother you. But this is the algebraic equation for redox. Redox tells you if this is an ionic substance, a polyatomic ionic substance that has no overall, it's not an ion, means that its overall charge is 0. Then each element charge must add up to 0. Also gives you some rules, and these rules are set in stone. For example, any cation will take the overall charge of that ion itself. So copper is 2 plus, sodium is 1 plus, potassium is 1 plus. These charges is the same as the group number or valence number. For elements that are non-metal, it is dependent on how they react that they will present you with different charge, which is why they ask you to focus on sulfur. For oxygen, oxygen is always -2, except when it is in hydrogen peroxide. In that case, it will react with hydrogen and therefore will have -1 charge. So there's the only difference for hydrogen peroxide. So let's proceed with that. So we said that copper is 2 plus. We have worked it out more than once. So we know that this is +2 plus sulfur is the unknown plus -2 times 4, which is equal to 0. That -2 comes from the oxygen. So that's +2 plus S minus 8 is equal to 0. S minus 6 is equal to 0. Therefore, S is equal to positive 6. Everybody saw that or understood that?
Yes, sir.
And sulfur is always +2 +6 when it is in a sulfate. And overall charge for a sulfate is 2 minus. So it will always be equal to +6. So this is +6. Any question? Anybody actually want to ask me anything?
Sir, what's the answer?
+6.
Okay.
All right. At the anode, hydroxide.
Sir, somebody said they don't understand, so if you could redo it.
All right, no problem. Let me write over this side. Copper sulfate. What we're doing is splitting up each individual element, and then we are going to assign their charges to them. And because it is uncharged overall, it will be equal to 0. So copper plus sulfur plus 4 times oxygen will be equal to 0. Copper, which is plus 2, plus sulfur, which is unknown, plus 4 times minus 2, because that's the change of charge on oxygen, will be equal to 0. We now expand all of these brackets, and we end up with minus 8 equal to 0. We now add these integers, so it's S minus 6 is equal to 0. And of course, we know if we minus 6 on both sides, when a 6 goes over to the equal sign, it will equal positive.
Sir, question, could they ask you to deduct the reduction state? Or is this oxidation state?
No, oxidation state.
Okay.
Oxidation state and reduction state. Well, reduction state in its technical term is not something that you explore. You may end up with looking at it at CAPE, but it's not called a reduction state. It's a equation that is written in its reduction order. Most of these that you're looking at will be in the oxidation direction. Oxidation state is actually a part of the periodic table. When you look at the group number, and the group number tells you the oxidation state, which is why I can tell you off the bat that sodium is +1, potassium is +1, calcium is +2, because they are in group 2, and sodium and potassium is in group 1. Any other question?
Sir,
Yes, go ahead.
I still don't understand how you got the 6.
Still don't understand how to calculate the oxidation state. Is that what you said?
How did you get the 6? Because I know you have the +2 plus the x minus 8. But then you have s minus 6.
Oh, so this is your problem. That's the problem, right?
Yes,
All right,
sir.
this is how we got that. +2 minus 8. How much is that equal to? You have 2, but you owe 8. How much should you have at the end of the day? Or not have? Answering? You owe 2. Sorry, you have 2, but you owe 8. If you give those 2, how much would you have at the end of the day? Or how much would you owe at the end of the day?
6, sir.
Will be minus 6. See here? Same thing there. Get it now?
Yes, sir.
All right, nice. All right, so at the anode, the hydroxide ions are discharged in preference to the sulfide ions. Why? Why would the hydroxide ions be discharged instead of the sulfide ions?
Because they're lower in the reactivity series,
What is lower in the reactivity?
the hydroxide ions.
The hydroxide ions. Anybody else? You're breaking up. Not hearing anything that is. Is it possible for you to type? A minute, please.
So you hear me now, sir?
Sir, is it because of the reactivity series?
All right, type it, let me check.
Sir, I was saying, is it because of the reactivity series?
Yes, so the reactivity series will be the one that decides what actually is discharged from what is not discharged. So sulfate in actuality is actually never discharged. In order to get sulfate, you'd have to have it in a molten state and not an ionic state, because hydroxide is always lower than it. So the order is always chlorine, sulfate, nitrate, then chlorine, bromine, iodine, and then lastly hydroxide. So you have to know the electrochemical series in order to answer those questions correctly. Next question asks for the equation of the anode. Anybody knows the equation?
Let me see. So the anode would be the sulfate. So
Sulfate? No, we just said that hydroxide will be discharged over sulfate, so no.
4OH.
4OH, go ahead.
4OH aqueous produces 2H2O liquid plus O2 liquid plus 4 electrons.
O2 can never be liquid. O2 is always a gas.
Oh my God.
So the hydroxide ion is discharged as oxygen gas. Other product includes water. So, of course, there was something wrong with that equation, but essentially it is correct. It is 4OH minus aqueous, you have to put the state, which goes to 2H2O liquid plus O2 gas plus 4 electrons. And these things actually never changes once it's hydroxide that is being discharged. That will always be the equation. So if you can register that, you will never need to, you will never forget that reaction once you see an hydroxide being discharged. From the equation written in C, state whether the reaction at the anode is oxidation or reduction, and give an example, give an explanation for your. So the reaction at the anode, would it be an oxidation? Would it be a reduction? And why?
Oxidation, sir,
Why is it oxidation?
because it loses electrons.
Loses electrons. Anybody else?
And there was an increase in the oxidation state.
There's an increase in the oxidation state. No, there was no increase in the oxidation state in this case. So the answer, what you said was correct. It is oxidation, but there's only one way you can use to explain it, which is the loss of electrons. You're not going to necessarily see the increase in oxidation state or decrease in oxidation state in a reaction like this. So, of course, oil rig tells you that oxidation is the loss of electrons. Therefore, a reaction like this will always be an oxidation. And oxidation occurs at the anode. However, if you write oxidation occurs at the anode, you will not get any mark because that does not explain your answer. So let's go back to this. But there's one question I need to look at before I reveal out, which is the following. State two change that would occur in the electrode in this case. Two changes that would occur in the electrode.
So it will start deteriorating.
Start deteriorating. Start deteriorating.
So like it will start to break down and maybe a color change.
Breakdown and color change.
There was the effervescence, sir, at the anode.
Effervescence. Remember, it asks you for electrolyte.
The color.
Electrolyte.
Solution.
So the color would fade definitely because what color is this, by the way?
Blue.
That's blue because it's copper 2 plus. So the color will start to fade. That's the first thing you must note. Also, what you will also note that the copper that is in there will start to dislodge. So you'll now start to deposit of copper within the solution. And then lastly, the electrolyte will now become acidic. Now, why would it be acidic? Yes? Go ahead. Why would it be acidic? Nobody knows?
Yes, sir, because it contains a high number of, would it be because it contains a high number of hydrogen ions, sir? Would it be that?
Hydrogen, yes. Hydrogen and something else will make the specific acid. What is it?
Hydrogen and oxygen.
No, hydrogen sulfate. Remember the copper sulfate is now broken up. Remember that a while ago? Changes in the electrolyte, copper start to deposit. So now sulfate is now present in the electrolyte. Teacher? Changes in the electrolyte. Color start to fade, no longer blue because of the splitting of the copper and the sulfate.
So go from blue to colorless or just pale?
It will eventually reach colorless if
Okay.
you have enough, if the reaction goes on long enough. And it will become acidic because the hydrogen that is in surplus will now react with the sulfate to form sulfuric acid. And the copper particles are now dislodged there because it splits with the sulfate. So it is now really receiving electrons to become solid copper. Any question?
No, sir. Can you repeat what you just said, please, sir? I didn't hear it properly.
All right, are you seeing what's on the screen?
Yes, sir.
All right, so the change in electrolyte, it will no longer be blue, it will fade until it eventually becomes colorless if the reaction runs long enough. The surplus of H plus ion, which you mentioned earlier, will now bond with the sulfate ion to form sulfuric acid, so it becomes more acidic. And the copper particles from the sulfate will now fall from this electrolyte and dislodge into the electrolyte itself, especially near the electrodes themselves. And so copper will stay there as a solid.
Oh, okay. So what is this, sir? The copper would fall, sir? Or
Yes.
the copper would fall?
Yes. Copper will now be dislodged in the electrolyte.
Okay, sir. So
that is why it is fading, actually.
So,
because
sir,
it
would that
is-
be the remaining copper which would fall, or all the copper ions?
If it runs long enough, then all the copper could fall out. But if it runs only for a short time, only some of the copper. If it runs for a short time, it will just get paler. And the paleness that you see is because of the splitting of the copper and sulfate. So the amount of copper that you will see will always depend on the amount and how long you run the reaction.
Yes, sir.
Clear? Any other question? All right. We move to the last part of it, then we go to some organic chemistry. So, question: determine the mass of copper in grams which we deposited at the cathode when 5 amps of current passes through the cell for half an hour. We know the equation
I'm
again.
not seeing the question.
We're not seeing the screen, sir.
Oh, sorry. Here it is.
Circle is thanks.
Determine the mass of copper in grams, which is deposited at the cathode when 5 amps of current passes through the electron cell for half an hour. We know to calculate this, it is, what's the equation again?
Q equal I times T.
Q equal IT. We know I is equal to 5. And T is equal to 30 times 60.
1,800.
Then when we find that value for Q, it is now compared to Faraday's. How many electrons are in this reaction?
2
2. So it is now 2 Farad.
times 97.
Therefore, it is 90. And that's what it is compared to. So the Q value that you get is now divided by 193,000. That value will give you the mole. Now the mole that you get, how do you move from mole to mass?
Sir, come again. What did you say?
What do you want me to repeat?
What you just asked us?
How you move from moles to mass?
3 times by the molar mass.
All right, so to get mass, it is moles times the relative atomic mass because it is only an atom. Which is, they give you 64, and that will give you the mass in grams. You will see it work out. I just walking it through the steps. Now it asks you, how could you modify this to obtain pure copper from impure copper, which you just mentioned a while ago, in the space where there's no modification, right? No modification. So, how would we modify the anode? How would we modify the cathode? And how would we modify the electrolyte?
So for the anode, you could use few strips of impure substances.
Which impure substance? Remember, they asked you
Copper,
for a
sir.
specific
Copper.
question, you know, so you have to answer the specific question.
So could use few strips of impure copper.
Yes, so the impure copper at the anode.
And we could use pure strips of copper at the cathode.
Yes, so the copper would have a pure strip of copper. What about the
And at the
electrolyte?
electrode, no modification required.
No electrolyte. The electrolyte has no modification, so it's still the copper sulfate that you would use.
So if we're going further, can just go back up at the top part there, so and explain back for me, please.
To equality?
Yes, sir, right there.
Yeah,
sir.
man, we're going to that right now. See it here now? Whatever I write on the slide, it's in the PowerPoint. So Q is equal to IT, that's the equation we get. First and foremost, you need to know what is being, which we're looking at. Is it the cathode, is it the anode? Since it is copper, we know that it is 2 electrons. So this will be useful. So Q is equal to IT, I is equal to 5 amps, T is equal to 30 times 60, because it has to be in second. That equals 9,000 coulombs. Since it is expected that 2 moles of electron will be discharged, and Faraday says that for each mole of electron that is in charge, it is equal to 96,500. Since it is 2 moles from this reaction, of course, since it is 2 moles, this is where it comes from. We know that it is 2 parts that we should be comparing it to instead of 1. Somebody's mic. You then divide that 9,000 that you calculate by 96,000. There's more than one way to do it, I should say. 96,000 divided by the, sorry, let me start over. 9,000 divided by the 96,500. That will give you the farad. But because it is 2, you know, divide it by 2 to get the mole. Alternately, you could do it the way that we did it first, which is the 9,000 divided by the 2 times 96,500, which will give you directly the 0.47 mole. Not sure which way you were taught, but both ways will work out the same way because the 2, you're always dividing by the 2 at the end of the day. And to move from moles to mass, you multiply the relative atomic mass, which is 64, by the moles and get 2.9 grams. Hope this one was better.
Repeat.
This one was better for you? Could you follow
Yes,
this
sir.
one?
Yes, sir.
All right, any question?
Yes, sir.
No, sir.
Do you know how to modify it with the impure or pure copper?
Or do you know what to modify it with?
Yes, sir.
All right, so in electrolysis, in refinery, which we have been looking at so far, with refinery, the impure is always the anode because of the direction of electron flow. So it will always flow from the anode to the cathode. So you need the electricity to break up the impurity first, so that when the electrons reach the cathode, it will pull whatever you're trying to purify. It could be copper, could be any other metal. Pull it towards the cathode so it deposits on it.
Okay, sir. Thanks.
Any other question? All right. Electrochemistry, sorry, not electrochemistry, organic chemistry. Let me cue up the paper. This is 2012 question 3. Same year, different question. Now, this is a pretty simple question. However,
Sir, we're not seeing the questions here.
yeah, I'm going to load it. I'm clearing something. It's a pretty simple question. See it now?
Yes, sir.
It's a pretty simple question. I don't think it gets any easier than this. However, the biggest problem with this is that it is tricky. Tricky because when you see the structure, the first thing that you want to do is what? What is the first thing when you see the structure, what would you want to do?
Name them.
Name them. That's the first thing you want to do. Name them. Now, if you look at the question actually did not ask you to name them. See that? Now, one of it said name it. Are you noticing that?
Yes, sir.
So when you're doing the question, you have to first read the instructions before obeying your impulses, because that is what caused many persons who have done this question wrong. So the first thing it asks is write the name of the homologous series to which A and B belongs to. What homologous series is A?
Alkene.
Alkene.
Alkene, or you spell alkene?
Alkene.
That is also a common mistake spelling. Alkene. If you don't spell it correct, by the way, it is incorrect. And B?
Okay.
Alkane.
Spell it.
Alkane.
All right, then it asks for the general formula for the homologous series for A and B, not the formula of the compound, not the formula of the substance that you're seeing, but the general formula for the series. So let's go ahead.
For A, CnH2n.
CnH2n, not Cn plus H2n. That is incorrect.
So, sir,
Yes.
before someone wrote the general formula as CnHn2, would they give it wrong?
HN2, yes,
Yeah.
that is also incorrect.
Okay, sir.
All right, for B?
CnH2n plus 2.
All right. Everybody good so far?
Yes, sir.
Yes, sir.
Now, let me remind you what A and B is. Take a mental picture of it because you're going to use it on there. If I zoom out, you may not be able to see. All right. So it says both A and B react with chlorine, but under different conditions. Unnecessary condition for B to react with chlorine. What is that condition?
Present of UV light, sir.
I hear UV light. Anything else?
Sir, heat.
Heat. Anything else?
A relative atmosphere mass is the average mass of an atom.
I didn't hear that. That was muffled. Tiana, repeat please.
Priority. Molecule.
Really not here. Presence of light. That's what I see in the chat. All right, so I hear heat.
So hydrogenation.
UV. Hydrogen what?
Hydrogenation.
The only thing that is required is UV light or sunlight. Sun produce UV light. Heat, absolutely not. And that is actually a very common misconception. Heat and temperature, not the correct response. It's only UV light or sunlight. Those are the only things that will get you this question correct. Now it says draw fully displayed structure of A and B when they react to chlorine. So what would happen in this reaction with A? What would happen in this reaction with B?
Sir,
Sir, the
in the
double bond
reaction
would
with
go
A, sir.
close with the chlorine.
Heard two person talking at once a while. Couldn't hear. I hear some more chlorine. Yes. The linear influence. Somebody want to repeat? One person.
Sir, the double bond in the alkene would break and it would form into 2 chlorine.
All right, double bond will break and then 2 chlorine will be added. Anything else? What was that other person saying? All right. Let's make a quick look at A again. So it is C double bond C. 3 carbons, 1 double bond. So it is C double bond C. Just moving that out there, but this should be a double bond. Put in a single bond now. And you're saying that both sides will now have chlorine. What about B? What would happen with B?
Sir, substitution.
Substitution, what would be substituted?
Sir, two of the hydrogen would be for the chlorine, sir.
2 of the hydrogen will be replaced by the chlorine. That's what everybody says, right?
Yes.
Yes?
Yes, sir.
Anybody object? Let me write what I said. So 2 all right, so this is what you said would happen, right?
Question, sir.
Yes, go ahead.
Sir, can the 2 chlorine go anywhere on the chain, sir?
Well, no. In fact, this structure is not correct. Only 1 chlorine can be substituted at a time. That's how unreactive the alkanes are. So the alkenes will accept the 2 chlorine at the same time. But for the alkane, only 1 can be substituted at a time. And it really has anywhere it can choose to be a part of the chain. Can go here, can go there. There are some technicalities about it, but not that those technically apply to your level yet. So some compounds actually can form multiple different species. So the Cl can go here, can also go here. But if it goes here, it is the same as going here. If it goes here, it is the same as going there. So it is, it also has preference whether I will choose the second or the first carbon. So again, that's above your level. So it's actually one chlorine that will be substituted, not two. Any other question or comment?
Sir, so how do we know that's what we're supposed to do?
Repeat.
How do we know that these are what we're supposed to draw?
What do you mean?
Like, how do we know, like, we're supposed to add only 2 chlorides to this?
All right, or you know that you're supposed to add only 2 chlorine. Well, based on this, chlorine exists as Cl2. Chlorine does not exist as Cl. Chlorine gas, anything in group 7 exists as a diatom. So F2, Cl2, Br2, I2, At2, which is acetate.
Okay, sir. Sir, so from it's a diatomic molecule, and they asked us, to show a displayed structure, fully displayed structure with any of the diatomic molecules. We know that we're just going to substitute a hydrogen for one of the diatomic molecules.
If it is an alkane, if it's an alkene, then it's an addition across the double bond. So they may not give you a Cl, they may give you a HCl. They could give you a Br2, they could give you a HBr. These are the most common ones. Once it's an alkene, these two things will substitute across the bond. Once it's an alkane, only one of these things will be replaced, and it is going to be the halide.
Sir, run that by me again.
All right. He was asking if it's anytime it's a hydrocarbon, if it will always be the 2 species that will attach across replacing an H. And I'm saying for alkene, it's not replacing an H, it's breaking the double bond and then adding itself across those 2 empty spaces. So for Br2, which is an halide, it will exist as bromine bonded to a bromine. That's how it is. So this will add to one end of the carbon, that will add to the other end of the carbon. If it is HBr on the other hand, Br will add to one end, the hydrogen will also add to the other end.
Oh, okay, I see what's going on.
However, if it's an alkane, only one thing can go at a time. And it will never be the hydrogen, it will always be the halide. So if you actually wanted 2 chlorine to be added to this butane, you'd have to run this reaction twice. While for the alkane, which is this this has now become propane. It was a propene before. All you need to do is run this reaction once.
All right, sir.
Everybody clear on that?
Yes, sir.
All right. So I have the all right, we'll have to go through. All right, so for this one, it gives you a reaction sequence. It tells you that we're starting off with an alcohol D. It didn't ask you to identify these things. Then it gives you E, gives you J, and asks you to state the role of potassium dichromate. What is the purpose of the dichromate?
Sir, it's a catalyst, sir.
Catalyst? What else? All right. So reactions in organic chemistry. This reaction, whenever you see dichromate, it is moving alcohol. What is the functional group for alcohol?
OH.
OH. So that's the compound. And now what is formed is C double bond O, OH. So you move from alcohol to a carboxylic acid. This, the purpose of this is actually to oxidize the alcohol being converted into a carboxylic acid.
Say it again.
The purpose of the dichromate, if you look at it, it has many O's. O's, they are very significant. This alcohol B that you're looking at, the functional group is OH.
So wait, why wouldn't you say?
Ask me a question. All right. So whenever you move from alcohol to a carboxylic acid, you have to undergo the process of oxidation. So this, if you remember, permanganate, potassium permanganate, and dichromate, they are strong oxidizing groups. And so its purpose is to oxidize the alcohol into carboxylic acid. So while it is used as an catalyst in many reactions, in this case, it is moving as an oxidizing agent. Good?
So the role of the I'm forgetting name, but the role is to be oxidized, all right, or
Yes.
oxidized.
Yeah, oxidizing agent. So it gives the oxygen to the alcohol to form this double bond O here. Are we good?
Yes, sir.
All right.
Question, sir.
Go ahead.
Sir, what is that process called, sir?
Oxidation. Any other question?
Okay, sir.
Any other question? All right. Now, the next part asks about whenever you add a carboxylic acid to a metal, the metal will always add itself here. So we'll remove the H is the weakest link, and it will be substituted by magnesium. We know that magnesium is more reactive than hydrogen from the electrochemical and the metal reactivity theory. You remember that, right?
Yes, sir.
So repeat what you just said.
Magnesium, Mg, is more reactive than hydrogen, and so it will kick off hydrogen, take its space. Good?
Yes, sir.
So for carboxylic acid, the reaction actually takes place at the OH group. It won't take place here because this is a stronger bond than the OH. So the Mg will now be a part of this part of the chain. So this now turns to Mg. And what is formed as a side group is water. H2O. So it is CH3 C O O M G. That's water.
So what were you saying about the H2O? Why is there? Yeah, why
Because-
is there?
Why is H2O?
Yeah.
Magnesium is 2 plus.
Mm-hmm.
Hydrogen is 1 plus. So whenever this dissociates from it, oxygen will be 2 plus, sorry, 2 minus. So you need 2 hydrogen to actually fuse with the 1 oxygen.
So what you have over this with the change?
Over where? It's specific.
This, sir. Wait, that's it just wrote.
Oh, hold on, let me see if I can get rid of your confusion. So here, oxygen is 2 minus. That's what I wrote here. All right, that's not what you're talking about. This is CH3 COOMG plus H2O.
So where's the CH3COOMG?
This, it says, write the balance equation for E. E is this. CH3 COOMG plus the water that is formed. Still not seen it?
So how you saw the water?
Let me put it up. The structure for E, CH3, is here.
Yes, sir.
CH3 COOOH. Now this H is going to be replaced by magnesium because magnesium is more reactive. So it now forms CH3COO2 because this, when this reacts, it have a charge of -1, it have a charge of +1. So you'll need 2 of these to actually react with the magnesium. And as such, H2 is formed, which now reacts with this 2 minus oxygen to form water. Follow that?
Sir, do it again, please.
Question, sir.
Go ahead.
No, come on. If
Go ahead.
So what would be the state symbols here?
When do we need the state symbol?
So what would be the state symbols in this equation, sir?
Magnesium oxide is solid.
you know what,
Alcohol, alcohol is aqueous, a liquid. This is now solid, and this is now aqueous, and this is now liquid. L
come on.
A Q
Man, come on.
solid and aqueous. All right, back to explaining how we get this reaction. Now, the reaction between species is, of course, a balancing act by the negatives and the positives combining. So for this negative, which is CH3COO negative, is balanced by this single H plus. That's how this is formed if it should split up into its ion. This, ignore this 2 forming. So this is what it would form. For magnesium oxide, this is 2 plus, and this is 2 minus. That's how it is formed. Now, if the H plus is removed and replaced by magnesium, you'll now need 2 of these to balance with the magnesium, which is why this has the 2 there, to get the overall charge of 2 minus. So it's now 2 minus, or minus times 2 plus 2 plus, and now it balances out. The oxygen is 2 minus, so you need 2 hydrogen to satisfy the 1 oxygen.
Okay, sir.
Any other question?
No, sir.
All right, now we're supposed to finish now, but I can spare 30 more minutes for those who are interested, if you're not clashing with anything else.
Sir, we can continue.
All right. Now, the gas, the question, so the next question is, describe one chemical test that could be used to identify the gas given off from the reaction with compound E and solid calcium carbonate. Anytime they ask you about calcium carbonate, there's only one gas that you're testing. What gas is that?
Carbon.
Right, sir.
Carbon.
Repeat. Calcium.
Carbon dioxide.
Carbon dioxide. Carbon dioxide, also known as lime water. And what is it? What is the test?
Could I use a squeaky pop, sir?
What?
No, no, not squeaky pop. Tony and yes, you can get the recording. I will give it to 1x so that they can send
Sir,
it.
if you put a splint over it, it will go out.
No.
That's
No,
not
no,
high.
no. A joke them on it. A joke them a make.
No.
A joke them a make.
Sir, we can use a lime water and a true, sir. I'm making for sure say like carbon dioxide, sir, without like cloudy, sir.
Yes,
That
it
one, sir.
turns lime water milky.
No.
Yes, so it gets cloudy white. So that's essentially what it's asking. You would bubble that gas into some calcium. So it says solid calcium carbonate. Of course, you'll have to mix this, turn it into a solution, bubble it inside it, and then you'll see the observation, which is turn it milky white. So the last question is, what would be the homologous series for J? And all you need to do is look again at the functional group. So which functional group is this?
Esters.
Esters. Good.
Easy.
Awesome.
Esters.
So this is ester.
Sir,
Yes, go ahead.
what are esters?
Esters are known to be the group with C, double bond O with another R group. So now the H has been replaced. We'll put it. This H has now been replaced with another R group, which is this CH3. If this C double bond OH is carboxylic acid, C double bond O, R group. So this R group, which is a methyl currently, could be another group. Solomon.
Sir, what would the ester be, sir?
What would what?
What would the ester be, sir?
This ester, ethyl ethanoate.
Okay, sir. Sir, so
Sorry,
what would I
methyl
name it,
ethanoate.
sir?
Methyl ethanoate. CH3.
Sir, or you name it, sir?
Convention is that the side group, which is added, goes first. If it's an alkyl group, it is methyl, ethyl, propyl. And then the ending, which is the acidic part, is called anoate. So this, which is ethanol, turns to ethanoic acid, now turns ethanoic. And this is the R group, so it's methyl ethanoic.
Okay, sir.
Any other question? All right, we're good. So let me queue up the next one in the meantime. June 2010. Energetics is here, but not rate of reaction. So we can move to another organic chemistry. 2020 question C.
Sir.
Yes.
So before you go, sir, you can do like energetic calculation, sir.
No, bro, that's easy. All I have to do is just remember what to do. Without even moles in it something.
Not everyone learns how to do energetics, Davian.
If you want to give me the question, sure, we can do it if you want. Since we're running out of time. You can give me your question suggestion that you want to do. If we can find it, we can look at it.
Yeah, I have an energetics question.
Go ahead.
So it said, if the heat when 1 mole of water is produced in a neutralization reaction, 50 centimeter cube of sodium hydroxide solution with
I know.
T.
I know, I'm getting
So,
that echo light from it. Is it, which year is it?
so I'm not sure.
Oh, it's just one from class.
Mhm.
All right, go ahead. Or if you can type it. Let me see. All right, so for the energetic, once it's heat of neutralization, it is going to be Q is equal to MC delta T, where M is of course the mass. C is the heat of vaporization, sorry, A specific heat of capacity for water, which is 4.2, and then you find a change in temperature. And that is a staple, that doesn't change. Just like the Faraday calculation. But if you can find one, certainly we can look at it. Topic of we sorry. Extraction of metal, or are we with that one? Yes, no? Extraction of metal and metal in living system. I have a question with both of those. You want to look at that?
So we could look on that.
All right. All right. All right, so the raw materials necessary for the extraction of iron from its ore are an iron ore, coke, and limestone. First, it says write the chemical formula for 1 ore of iron, because there are more than one. Outline the steps involved in the extraction of the iron from the ore. Write a balanced equation for the steps, and there are 3 steps. Stainless steel and alloy of iron is used to make cooking utensils. So there's 2 reasons why stainless steel is used instead of the pure iron. Besides cooking utensils, what other use is there for the for iron alloys? And name the compound of iron that is found in blood to explain how the lack of iron will affect the body. All right, so let's go. You're ready. Chemical formula for 1 iron ore.
Fe2O3.
Fe2O3. Yes. What's the name of that, if you don't mind?
Hematite.
Hematite, yes. Any other? All right. So we have hematite, magnetite, and we have siderite. So hematite, Fe2O3, magnetite, Fe3O4, siderite, which is either iron carbonate or iron sulfide, Fe3O3 or Fe2S3. Now, the 3 steps, doesn't matter which one you use, the 3 steps are pretty much the same because it occurs in the same furnace. And it is done in the first thing, the coke is burned in air to produce carbon dioxide. Now that carbon dioxide is reduced to form carbon monoxide. And that carbon monoxide, when it reduces, is used to reduce the iron ore. And that actually gets the iron from the ore itself and splitting it, producing carbon dioxide. Now that reaction, I will show that reaction later. But if you know the different steps, you can be guided by the reaction itself. This one, not much like the other question because this is more of a writing question than anything calculating or applying anything. This is really swatting. So I don't really like the swatting question because if you don't remember one thing, it can tend to throw you off. Some of you may like up here. A question? No? All right. But we can move to C, which says why stainless steel used more than the iron itself? Can anybody suggest why stainless steel is used than the metal itself?
Because the metal is rust quicker than the stainless steel.
So stainless steel tend to be rust resistant. And if you look at most of the jewelry or appliances these days, they're being made from stainless steel so that it doesn't tarnish and last very longer. Any other suggestion?
Yeah, so basically the stainless steel is less reactive than the metal.
Less reactive. It is kind of inert, yes. And that is why, that is another part of the reason. Any other reason?
Sir, someone wrote in the chat that stainless steel is an alloy, so it is better to use.
All right, but that doesn't explain why you'd use it for your, saying it is better to use it, actually not a reason. Any other suggestion? All right. So it is rust resistant, is stronger, it is more attractive, reduce the transfer of iron to our body as well. And as was mentioned, it is less reactive. Apart from utensils, where else could you find iron being used?
Is there in the steels?
In where?
So jewelry would be one.
Jewelry. Yes, jewelry would be one.
Sir?
Yes, jewelry would be one.
Trophies could be one.
What was that?
Trophies.
I don't think I heard it.
Sir, I said trophies.
Oh, trophies. No, you don't put stainless steel in trophy per se. But I guess I'm not
So what
sure.
about like
It's
some
not a common use.
construction materials?
Somewhat
Surgical equipment.
Materials.
like tools.
Yeah.
Yeah, tools. Mm-hmm.
The kitchen pipe would be one, like, or your pipes overall.
Pipes. Well, that be a very expensive pipe, so they don't normally just use that. Pipe, I guess. What about the all important vehicle? Then that's the first thing somebody would have said, vehicle. You
Vehicle.
don't, yeah,
What?
planes, cars.
Oh no, man, that's not what I said.
All right, so the question, the last question asks about iron inside the body. Which iron is found inside the body? Name the compound of iron that is found in the blood and explain how the lack of iron affects the human body. Anybody wants to explain that one?
Sir, so the lack of iron in your blood allow one to become anemic as well as to feel fatigue. So they don't have enough energy to do anything.
What? All right. What is the iron? In what form is iron found inside the blood?
Liquid.
Repeat.
Sir, liquid.
No, iron is never liquid.
Sir, somebody said hemoglobin. I don't know.
Hemoglobin. Yes, Abigail, that is correct. Hemoglobin. And what is the function of hemoglobin?
To produce red blood cells.
For
Transport.
transport what?
Of oxygen, carry oxygen around the body.
All right, so you calculate oxygen. Carries around oxygen around the body. Yes. Let me put that up so you can see it. All right. Now, let me see. Oh, the question was that a reaction of 100 ml of 1.3 moles HCl and 100 ml of 1.76 moles of sodium hydroxide is monitored, and the following temperature were recorded. The temperature was 24.6, final temperature 38.8. Calculate delta H for this reaction. All right, so we can do this question before we.
It's not on screen for me.
I was just reading it because I know you were looking at this one. And may put it up so we can. Here. This is a classwork question, huh? All right, this is it. All right, so the reaction of 100 mils of 1.3 moles of HCl and 100 mils of 1.7 moles of sodium hydroxide is monitored. And the following temperature recorded: starting temperature 24.6 degrees C and final temperature 38.8 degrees C. Calculate the delta H for the reaction. All right. Let's go. How do we work this? Go ahead, Roger. You have a question?
All right, sir. So first we'll find the total mass, sir. Find the total mass.
All right, that's good, but you should realize that there is no mass here. How do we actually find the mass?
So you would say you'd find the volume because it's the volume is also equivalent to the mass of water. No. Not water.
Close. Now the density of water is estimated to 1, and so the mass of any volume of water is also 1. Since these solutions that you are making up will contain water, then the mass will be equal to the volume as well. So, yes, you are saying, how do you find the mass? Yes, Roger, or anybody else?
All right, sir. So you'd find you add the 100 milliliters of you add the 200 milliliters, right, sir? 100
You say add the 100 to?
And you add the other 100, sir.
The 100.
You get 200 milliliters.
You get 200 mil.
And you'll have to find so how come it's not milliliters cube? Okay. I
it's
heard
not
that
multiplied, that's a product.
All right, sir. You get that. And then you're going to have to find the change in the temperature as well.
So you find a change in the temperature by
subtracting the 38 degrees Celsius from the 24.6 degrees Celsius.
so it's a 38.
The 20.
And by the way, gentle people, while you are doing your calculations, do not leave out a unit. Units will cost you. And how much did you get for this?
Let me check.
14.2 degrees Celsius.
14.2 degrees Celsius. All right. Anything else?
Yes, so you also need to find the capacity, sir, the heat capacity.
You don't find it. You
But
don't find what is a standard. So it is given to you. And what
Yes.
would C be? What would it be?
Okay.
4.2
Unit.
Joules per moles, is it, or something?
joules per degree Celsius.
But sir, I don't see where they gave us a constant.
This seems like it's a classwork question.
Okay.
So just working out the classwork question. I don't know where exactly she get it from, but this, as I said, it seemed like it's a classwork question.
So the 4.2 joules per gram per degree Celsius. What were we trying to find again? What did we do to get that?
Where do you get that standard?
Yes, sir.
It is always given to you.
Oh.
It is the specific heat capacity of water.
Yeah, I just realized that.
Since your solution will be like water, it is always.
Question.
Go ahead.
Is it because of water it did not change the ml?
Because it's not
The
water.
unit.
I don't understand.
All right, so for example, when I am doing these questions in class, I it's the first time seeing one of these class questions with ml, and I'm able to see if it's gram or centimeters.
Oh, centimeter cube.
Yes, sir.
Centimeter cube is the same as milliliter.
Okay.
They're the same unit. If you look at your water bottle, you'll see milliliter. If you look at your measuring cylinder, you may see both of them. But they're the same unit, same volume. Any other question?
So how did I get the 4.2?
It is given to you.
Really?
Yes. Just like what they give you 1 farad is equal to 96,500 coulombs, this is a standard.
Okay.
So Q is equal to MC delta T and anybody work this out? 200 times 4.2 times 14.2 is equal to
11,928 joules.
how much?
11,928 joules.
All right. How do we proceed from this now? So find Q, and there's some assumption for Q as well, but I'll say them later. How do we proceed from this now? Anybody? Roger, you're
Sir?
out. How do we proceed from this now?
All right, sir. You'll mark down the table, sir. You put a table of the moles, and you put the table of the other of this. So you say that is equal to 1 gram of moles, I think. And then you'll see what. Then
You
you'll.
say that is equal to 1 gram of moles.
Yes, sir.
There's something that you must do. What are you missing?
Sir, would you find it's? I don't think you'd find the ratio, but you'll have to find how much of that would give you 1.35 moles of HCl. Oh, and you'll add
Sorry.
the.
Yes,
Sir,
I'm listening. I'm listening.
Sir, would you add the 1.35 to the 1.76?
1.7.
Sir,
Hold
would
on.
you change joules to kilojoules?
No, not yet. Hold on, give me a second, please. Yeah, sorry about that.
Sir, would
Yes.
you change the 4.2 degrees Celsius to Kelvin?
No.
Sorry, you would change the joules to kilojoules.
Not yet. All right. This is what we are missing. You are missing the fact that Q that you calculate is in 1 mole, is per mole of water. You have not looked at the equation yet, which is what you actually use to get the moles. You don't remember writing an equation? No?
No, sir.
Right?
No.
Right? So you have to write the balance equation. This is a neutralization. So a neutralization is dependent on the number of water that you find. So you have to write the equation, which is, yes, go ahead, Roger.
Sir, would you write the equation, then you'll find the molar ratio from the equation, sir? Is that it?
Yes, yes. So sodium hydroxide, by the way, they give you 2 concentrations. They will generally give you 1, but it doesn't really make a difference. You can choose any one that you want. Gives us sodium chloride plus water. So how many moles of water we get? 1 mole of water. Then you get 2 molarity. You can choose any one of them that you want. None of this is coming back to you?
Yes, sir.
All right, so I'm following you. What do we do next?
All right, sir. So the would the what you call it, their molar ratio be 1 to 2?
No, it can be 1 to 2. Look at it.
All right.
Sir, a
1 to
1-to-1
1.
ratio.
1 to 1.
1
Yes.
to 1.
1 to 1. Yes. Then seems like you never do enough. This is what we should have spent some time with. So you get the 1 to 1 ratio. Then find the number of moles.
Yes, sir. Then you'll find the unknown.
What is the unknown?
The un the unknown would be what you call it, the
Look at the question. What is the question asking you for?
the delta H of the reaction.
Delta H of the reaction. So you now need to first find how much is in 1 mole of water. This will not give you 1 mole of water when you calculate. So if you choose any one of them, this is 1.71. Anybody not following, I should ask? So 1.76
Not following.
in 1,000 then X in what's the volume? What's the volume?
Yes, sir.
What
The
is the
one
volume you were using?
200, sir.
No, sodium hydroxide.
Oh,
Volume of sodium hydroxide. Can I see
Sir,
the slide?
100, sir.
100, right there. So, of course, X will be equal to just dividing this by 10, so it is 0.176 mole of water. All right, how do we proceed now?
Where the quantity, the number of moles.
Repeat. Just broke up.
The quantity divided by the number of moles.
The quantity divided by the number of moles. Not understanding that.
11,928 divided by 0.176.
All right, but here's screen
Sir, so
stop.
sir, what we did a while ago was to find out the amount of what in water? MPa what? I can't really see.
Number of moles in water.
Oh.
MOL.
All right, sir. So
Hold on,
moving.
screen stop. Let me give it some time. All right, so this that you're looking at is the Q that you just found is for 1 mole. Right? It is asking you to find the amount that is in the 0.5. So the last thing that you do is divide this Q value by the mole that is there, which is 0.176. Did you understand what I just said?
So sir, is the one the 11,928 divided by 0.176, right?
Yeah.
All right, sir.
Come on, man. All right. So this this Q value that you see, the assumption that this Q is in one mode, always in one mode. You want to find how much is in the amount of moles that you have, which is the 0.176. So it is per mole. So this is per mole. And so you have to divide Q by mole to get the amount that is there.
Oh, sir, we kind of confused to why. Like, sir, comedy confused to why. No, thanks.
You're confused to why you divide by moles?
Yes, sir, because normally
there,
Joules equal to energy, so.
there's always some assumption there that we have to read. And that is the assumption. Anybody got the answer?
Yes, sir.
What was it?
Yes, sir. 67,772.
Give me the kilojoules value.
Oh, the kilojoules oil.
So it's 67, so 6, 7. 67 what?
Say, you want the kilojoules value or the...
Yeah, give me the kilojoules value.
Sure, give us.
67,000. And lastly, you need to assign the sign. Is it a positive? Is it a negative? That has to be there. While they're working it out, is there any question? Anything I need to clear up?
Say 67.77 or
7.8 kilojoules per mole. Per mole. All right. And of course, because it is a heat of neutralization, it is always what sign? What sign is heat of neutralization?
Negative.
Negative. Always. So heat of solution is positive. Neutralization is negative. So this is negative. All right. So of course, this is one of those things that require way more time. Unfortunately, I have to go back to work. So the time that we are afforded. I hope that you would have learned something and that it will help you out throughout your exam. Yes, sir.
Thanks for your time, sir.
All right. No problem. Thanks for coming. Take
Thank
care.
you, sir.
And I will send this recording to 1X and they will disseminate. Are you in the MOTY group with Miss D?
Yes, sir.
All right. I will send it there as well.
Okay, sir.
Yo, Roger, send this in a chemistry group or something. Please and thanks. The recording negative.
All right.